Hello everyone, I am Kalyani Shashikant Chaudhary, Faculty of Civil Engineering Department from Vishwabharati Academy's College of Engineering, Ahilyanagaram. Here is the fourth lecture of Unit 1, that is Compass and Learning of Subject Survey. The content of this lecture is as follows. Number 1, local attraction. Number 2, included angle. Number 3, deep. Number 4, declination. And number 5, calculation of true bearing, that is numericals on declination. First of all, we will study what is local attraction. The deflection of magnetic needle from its original position due to various magnetic objects in the vicinity area is known as local attraction. For example, electric poles, transmission lines, cables, towers, heavy steel building, etc. Observe the diagram. Here you can see the deflection of magnetic needle. The magnetic needle gets deflected due to the magnetic elements. If local attraction is there, then the difference between forward bearing and back bearing is not equals to 180 degree. If the both stations are free from local attraction, then the difference between forward bearing and back bearing is equals to 180 degree. Now, the concept of included angle. When the two lines meet at a point, then the angle between them is called as included angle. There are two types of included angle. It depends upon the traverse direction. Number 1, interior angle, and number 2, exterior angle. Now, the exterior included angle. Okay. When the traverse direction is clockwise, then the included angle between them is exterior angle. For that, observe the diagram. Here is an open traverse. Okay. And its direction is clockwise. That is from A to B and B to C. So, their included angle is the exterior angle between them. Okay. Now, the interior included angle. When the traverse direction is anticlockwise, then the included angle between them is the interior angle. For that, observe the diagram carefully, and from that, you can easily understand what is interior angle. Here, you can see the closed traverse, okay? And its direction is anticlockwise. That is from A to B, B to C, and C to A. So, their included angle is the interior angle between them. In diagram, you can easily see this. Okay. For the exterior angle and interior angle, observe both these diagram. This is of open traverse and this closed diagram and closed traverse diagram. Observe this carefully. From this both diagram, you will easily understand the concept of interior angle and exterior angle. Now, the dip. Dip is the vertical angle which the magnetic needle makes with the horizontal plane. Observe the diagram carefully. Here you can see how the magnetic needle makes the angle with the horizontal. and this angle is nothing but the dip. Now, observe this diagram carefully and listen what I am saying. Okay, the dip at equator, that is east and west pole, is equals to 0 degree. Means the value of dip at equator is equals to 0 degree. Dip at north and south pole is equals to 90 degree. Isoclinic line. A line joining the points of equal dip is known as isoclinic line, and a clinic line, a line joining the points of zero dip, is known as a clinic line. Now the declination. The horizontal angle between true meridian, that is geographic north, and magnetic meridian, that is magnetic north, is known as declination. Declination at a point is not constant. Variation. The change in declination is called as variation. There are two types of declination: eastern declination and western declination. Eastern declination is always positive and western declination is always negative. As we discussed about the types of declination in before slide, here is the diagram of that. In diagram A, you can see the western declination, which is negative in nature, and in diagram B, you can see the eastern declination, which is positive in nature. Now, the agonic line. A line joining the points of equal declination is called as agonic line, and the line joining the points of zero declination is called as agonic line. Now, the important part, that is the numericals on it, start from this slide. First of all, you have to understand what is the formula. Okay, the formula is true bearing is equals to a magnetic bearing plus or minus the magnetic declination. When eastern declination, use positive sign, and when there is western declination, use the negative sign. Okay, this formula is very important. That is, true bearing is equals to magnetic bearing plus or minus magnetic declination. Now the numericals start. Okay. Question number 1. The true bearing of the line is 55 degree 30 minutes and the magnetic declination is 5 degree 20 minutes east. Then what is the magnetic bearing of that line? So here the declination given is 5 degree 20 minutes east, that is eastern declination. So use positive sign for that. The formula becomes now is true bearing is equals to magnetic bearing plus the magnetic declination. True bearing given is 55 degree 30 minutes is equals to, we have to find the magnetic bearing. So write as it is magnetic bearing plus declination given is 5 degree 20 minutes and positive sign because it is eastern declination. So 55 degree 30 minutes minus 5 degree 20 minutes is equals to the magnetic bearing. Therefore, the final answer is magnetic bearing is equals to 50 degree 10 minutes. Okay. For better understanding, pause the video and try to solve it with your own. Now the second question. The magnetic bearing of the line is 50 degree 10 minutes and the magnetic declination is 5 degree 20 minutes east. Then what is the true bearing of that line? Here the declination is 5 degree 20 minutes east. That is eastern declination. So use the positive sign. Now the formula becomes true bearing is equals to magnetic bearing plus magnetic declination. Magnetic bearing means 50 degree 10 minutes plus 5 degree 20 minutes magnetic declination. So the true bearing becomes 55 degree 30 minutes. Again, pause the video here and try to solve this problem with your own. Here I used the same value so that you can easily understand the difference between them. Now, the third question. The magnetic bearing of the line is 50 degree 10 minutes and the true bearing of the line is 55 degree 30 minutes. Then, what is the magnetic declination of that line? So, how to solve it? As we all know that true bearing is equals to magnetic bearing plus or minus magnetic declination. Here, the true bearing is given, that is 55 degree 30 minutes and magnetic bearing is equals to 50 degree 10 minutes plus or minus magnetic declination. 55 degree 30 minutes minus 50 degree 10 minutes is equals to plus or minus magnetic declination. So 5 degree 20 minutes is equals to plus or minus magnetic declination. Answer is positive. So it is eastern declination. So the final answer is magnetic declination is equals to 5 degree 20 minutes east. Okay. For better understanding, pause the video here and try to solve this with your own. Okay.